Hi guys, welcome back. And we were discussing the pair of straight lines, and in this video I want to continue our journey into the problems on pair of straight lines. Now diving into more difficult problems, but in this video still I am going to cover moderate type of problems. In the previous video I covered problems mostly relating the angle between the pair of straight lines, but in this video now I'm going to start talking about the relations between slopes and like that. So let's look at the first problem. So the first problem says that we are given with this equation: ax squared plus 2hxy plus by squared is equal to 0. So hopefully you already recognize this equation. This is indeed the pair of straight lines. This represents a pair of straight lines, and we are given with the condition that the slope of one of the lines, let's call this m1, is equal to m2 squared. So the slope of one of the lines is equal to the square of slope of the other line. We are given with this, and we have to prove a crazy thing. So we have to actually prove that a plus b upon h plus 8h square divided by ab is equal to 6. So we have to prove this crazy thing. So how can we do this? How can we arrive at this? Well, you might be remembering from the first video in which I derived the general formula for the angle between a pair of straight lines. I made use of these two relations. So first of all, m1 plus m2, the sum of the slopes is equal to minus 2h upon b, and I made use of m1 times m2, the product of the slopes is equal to a upon b, where a, b and h are definitely the coefficients of this general equation. Now let's actually make use of this given condition, and let's substitute this into this and this. So let's actually do that. So this is so substituting the value of m1 in the first relation, we have m2 squared plus m2 is equal to minus 2h upon b, and substituting the value of m1 in the second relation, we have m2 squared times m2 is equal to a upon b, which is the same thing as m2 cube is equal to a upon b. Now let's think about this for a second. So we have to prove this thing making use of this equation and this equation. So how can we use that? How can we conclude this using these two things? So first of all, look at these two equations. We have m2 term, but we don't have m2 term here. So what that means is that we have to eliminate m2. But how can we do that? Well, we see that we have a m2 cube term on the second equation, and in the first equation we have m2 squared term and just m2 term. Now it might not be obvious to you, but how can we eliminate is by just by cubing both sides of equation number. Let's say this is 1. So if we cube both sides of equation number 1 and then we substitute the value of m2 cube in this, probably I think we can arrive at this. So let's look at this. Let's look at what is going to happen if we do just that. So cubing both sides of equation number 1, we have m2 squared plus m2 whole cube is equal to this is just equal to minus 8h cube upon b cube, right? Just cubing right hand side and left hand side. Now you might be knowing the formula for a plus b whole cube. Hopefully you already know that, but in interest of those who don't, or you might have forgotten, those who might have forgotten, I am just writing the formula down again. A plus b whole cube is equal to a cube plus b cube plus 3 times the product of the terms multiplied by the sum of the terms a plus b. So this is the formula for a plus b whole cube, and we are going to make use of this formula here. So this is going to be, I'm talking about this is going to be equal to so the first term cube, which is equal to m2 raised to the power 6 plus m2 cube plus 3 times the product of the terms, which is m2 cube, times the sum of the terms, which is m2 square plus m2, and this is just going to be equal, this is just going to be equal to the right hand side, which is minus 8h cube upon p cube, right? And now let's make use of this. Since we have m cube, we also have m2 raised to the power 6, because you see m2 6 is just equal to a square upon b square from this relation, a square upon b square, and m2 cube we already have this, so this is just equal to a upon b, and then 3 times m2 cube, we again have this 3a upon b, and then finally m2 square plus m2. Well, we already had this in the beginning, so this is just equal to minus 2h upon b, so this is b square, and then we have minus 8h cube upon b cube. Now let's stop here and let's think about this for a second. So we have to prove this, and we have arrived at this. So if we have done all the steps up till this stage correctly, we can definitely say that these two equations are the same. And we know that if these two equations are the same, the corresponding terms should be the same. And by that I mean that let's look at one specific term here. So let's look at this term specifically, 8h square upon ab. So if these two equations are the same, this term should be the same. So if I look at this, I see a pattern here. I see 8 in the numerator and I see h in the numerator, even though the powers of h are different, and I also see b in the denominator. So I can say that I can arrive at this using this if I multiply this term by some factor here. And if I do that, and all these other terms also convert into the other terms of this equation, well, we can definitely say that these two equations are the same, and they should. If they are the same and we multiply this term by some common factor, this should indeed convert exactly into this equation. So let's see what that common factor is. So we have to convert this term into 8h square upon ab. So let's see how we can do that. First of all, we need a in the denominator, so we are going to multiply this by 1 upon a. We need b in the denominator, so what that means is we have to multiply by b square. We need h square in the numerator. Right now we have h cube, so we have to divide by h, and then finally we have to get rid of the negative sign, so we have to multiply by minus 1. So I think we are done. So once we do that, this becomes this, which is 8h square upon ab, and let's actually see what the left hand side or the LHS is going to become. So if I multiply LHS by this factor, common factor, minus b square upon ah, so since it's minus b square upon ah, this is just going to cancel. There's a negative sign here. Since there's a in the denominator, it's going to be a and minus a upon h, right? And then the second term, for the second term, we have this is going to be equal to minus b. We have a here, so minus b upon h. So this is minus b upon h. And then for the third term, we have this is the a is going to cancel here, and since we have the h in the denominator here, h is going to cancel. We have b square in the numerator, b square is going to cancel. We also have a negative sign, so it's going to be positive, so it's just going to be positive 6. So I think we are getting closer because we have a 6 here. So let's see if this exactly becomes this. So let me write, we are running out of space, so let me try to write it here. So the first term is minus a upon h. The second term is minus b upon h. Oops. The third term is just 6, and then on the RHS we have 8h square upon AB. Well, just bring these two terms on right hand side and we are just going to get exactly the same thing. So we just proved this. Now you can just imagine we just proved a crazy thing using, just making use of this relation that we had. And how did we arrive at this solution? Well, we just made use of this property of a plus b whole cube, and we did that to eliminate m2. And when we finally eliminated m2, still we were having a slightly different equation here, and then we multiplied this equation by a common factor, because I made an argument that if indeed these two equations are the same, then their corresponding terms should be the same. And what that basically means that this term 8h square upon ab and this term minus 8h cube divided by b cube should be the same. So I multiplied this equation by that common factor, and then this whole equation actually turned out to be the same thing as this equation. So hopefully that makes sense. Please comment if you don't understand anything, and thanks for watching.